Welcome back, traveler. The universe does not require our permission to change the rules of the game. We tend to think of the night sky as a permanent gallery, a fixed collection of distant lanterns hung there since before our ancestors first learned to point at things and give them names. But tonight, as the air feels sharp and dry against the glass of your window, we must consider the possibility that the gallery has added a new, uncatalogued exhibit. On December 30th, 2025, a signal was detected by the Terrestrial Impact Last Alert System, the survey we affectionately call ATLAS. It arrived not as a roar, but as a subtle, rhythmic pulse from the direction of the constellation Cetus. This was 3I Atlas. In the cold language of astrophysics, the prefix 3I designates the third interstellar object ever confirmed to enter our solar system, following in the mysterious footsteps of Oumuamua and Borisov. Yet, unlike its predecessors, 3I Atlas did not merely tumble through the dark like a lonely, jagged cigar or a dusty comet. It decelerated. According to the data gathered by the Mauna Loa Observatory, the object reduced its velocity by exactly 3.4 kilometers per second, without outgassing, without a tail, and without the help of any planetary gravity assist. This is an impossibility stack that defies our current understanding of celestial mechanics. What if this wasn't a rock at all, but a deliberate arrival? We are left with a mystery that echoes the ancient myth of the returning messenger, a silent visitor crossing the threshold of our domestic porch. As you settle into the warmth of your blankets, let the scale of this distance wash over you. Imagine standing on a frozen ridge, looking up at a void that is suddenly less empty than it was yesterday. Before we dive into the 3 terrifyingly beautiful explanations for this signal, I invite you to leave a comment telling me what time it is and where you are in the world tonight. Let us mark this moment together, because as the data streams in, we are forced to realize that the silence of the stars may have finally been broken by a whisper. The night is long, the signal is steady, and the story is only just beginning to wake. The detection of 3I Atlas on the night of December 30th was not met with sirens or shouting, but with the soft, rhythmic clicking of computer cooling fans in a darkened room in Hawaii. You are there, in spirit, watching the green glow of the monitors as the automated software flags a discrepancy that should not exist. The universe is generally quite good at following the laws of motion laid out by Isaac Newton, yet this object seems to treat those laws as mere suggestions rather than requirements. To understand the magnitude of this anomaly, we must first look at the way space usually behaves. Normally, an interstellar interloper enters our neighborhood at a high velocity, whipped along by the gravitational currents of the galaxy, and follows a predictable, hyperbolic path. It comes, it swings past the sun, and it leaves, never to return. But 3I Atlas behaved like a driver approaching a familiar driveway. It slowed down. To achieve this, it would have needed to expend an amount of energy equivalent to the detonation of several thousand nuclear warheads. Yet there was no flash, no heat signature, and no debris. Imagine you are standing on the deck of a ship in the middle of a vast, pitch-black ocean. You expect the waves to move with the wind, and you expect the driftwood to float aimlessly. But then, you see a piece of wood that stops against the current, hovers for a moment, and then begins to hum. That is what the astronomers at the Mauna Loa Observatory experienced when they looked at the telemetry for 3I Atlas. It was a ghost in the data, a phantom measurement that defied every calibration. They checked the sensors, they checked the cables, They checked the atmospheric moisture levels. They even checked to see if a stray microwave oven in the break room was leaking radiation. A humorous nod to the time, a similar signal at the park's observatory turned out to be someone heating up a burrito. But this was different. This signal was coming from a point in space precisely 400 million kilometers away, situated just beyond the orbit of Mars. The signal itself was a sequence of pulses, each lasting exactly 1.2 seconds, separated by gaps of 7 seconds. 7 is a lonely number, a prime number, a number that does not like to be divided. In the world of cryptography, primes are the building blocks of security, and in the world of biology, they often appear in the life cycles of cicadas to avoid predators. But in the vacuum of space, a 7-second pulse is an announcement. We are forced to consider the first of our 3 possibilities, that 3I Atlas is not a natural object, but a piece of technology. If we accept this, the humor of our situation becomes clear. For 60 years, humanity has been broadcasting television signals, radio shows, and satellite pings into the void, effectively shouting at the neighbors to see if anyone is home. And now, something has knocked on the door, but it didn't use radio. It used a directed gravitational ripple, a method of communication so advanced it makes our fiber optics look like tin cans tied together with string. As you lie there, feeling the weight of your own body against the mattress, think about the sheer patience required to send such a message. If 3I Atlas came from the nearest star system, Alpha Centauri, it would have been traveling for at least 40 years. If it came from further away, it might have been drifting through the cold for 10,000 years. It is a time capsule that has finally reached its destination. We often wonder what our own legacy will be, whether our buildings will stand or our books will be read. But here is an object that has outlasted civilizations. It is made of a material that does not corrode, powered by a source that does not deplete. It is the ultimate endurance athlete of the cosmos. The scientists call it an anomaly because they do not have a better word for a miracle that is wearing the clothes of a data point. The air in the observatory that night was heavy with the smell of ozone and old coffee. You can almost feel the static electricity in the room as the lead researcher, a woman who had spent 30 years studying the movements of asteroids, realized that her textbooks were now obsolete. There is a certain dry humor in being an expert on a subject, only to have the subject change its mind about how it works. She looked at the screen and saw the object's trajectory change from a straight line to a gentle curve. It was seeking a stable orbit. It was choosing a place to rest. This is the moment where the evidence deepens. We are no longer looking at a visitor passing through. We are looking at a guest who is planning to stay for dinner. To understand the scale of 3I Atlas, we must compare it to Oumuamua. Oumuamua was small, perhaps the size of a skyscraper, and it moved with a chaotic tumble. 3I Atlas is 500 meters long and perfectly stabilized. It does not rotate. It holds its position with the precision of a diamond-tipped needle. When the sun's light hits its surface, it does not reflect in a scattered way like a rock. It reflects in sharp, geometric beams. It is a mirror in a world of dust. We must ask ourselves what such an object wants. Does it want to observe us? Is it a scout? Or is it simply a piece of derelict equipment? A cosmic buoy left behind by a race that has long since moved on to other dimensions. The signal continues. 7 seconds of silence, then a pulse. 7 seconds of silence, then a pulse. It is a heartbeat. If you listen closely to the quiet of your own room, you might start to hear your own heart sync up with that distant, alien rhythm. It is a soothing thought, really. In a universe that often feels chaotic and random, here is something that is orderly. Here is something that is consistent. The signal is a tether, a thin line of logic connecting our small, blue planet to the vast, dark ocean. We are not just drifting anymore. We are being hailed. In the 19th century, we thought the canals on Mars were evidence of a dying civilization trying to move water. We were wrong. Of course, it was just an optical illusion and a bit of wishful thinking. But the December 30th signal is not an illusion. It has been verified by 13 different observatories across 3 continents. It is a hard, cold fact, and yet it feels like a dream. It feels like the moment in a story where the protagonist realizes that the world is much bigger than they ever imagined. As we move from this initial shock into the deeper layers of the mystery, we must keep our sense of humor. We are, after all, just a collection of carbon-based life forms trying to understand a stadium-sized computer made of unknown metal. It's a bit like a squirrel trying to understand a car engine. The squirrel knows the engine is hot and loud, but it doesn't know about spark plugs or fuel injection. We are the squirrels of the solar system, and 3I Atlas is the engine. As the first segment of our journey comes to a close, let the image of that glowing monitor stay with you. See the green lines of data as they march across the screen. Hear the hum of the computers. Feel the stillness of the Hawaiian night. The world is sleeping, unaware that the stars have started talking, but you are awake and you are listening. You are part of the small group of humans who knows that the great silence is over. The signal is real. The object is here. And the 3 things it could mean are more fascinating than anything we could have invented. But to understand the first of those things, we must go further into the mechanics of the impossible. We must look at how an object can move without fuel, and how a machine can think without a brain. The transition is subtle, like the shifting of a shadow, but once you see it, you can never go back to the way things were before. The ghost in the data has become the master of the house. To grasp why the scientific community is speaking in hushed tones about 3I Atlas, you have to imagine the sheer energy required to change the course of an object moving at 40,000 kilometers per hour. In the vacuum of space, there is no friction to slow you down, no air to push against. If you want to stop, you have to throw something away from you with equal and opposite force. This is the fundamental principle of rocketry, a law of physics that has remained unchanged since 1903, when Tsiolkovsky first wrote down the rocket equation. Yet, when the terrestrial impact last alert system tracked the deceleration of 3I Atlas, there was no plume of fire, no cloud of ionized gas, and no infrared signature of a heat shield. It was as if the object simply decided to be slower. This brings us to a terrifyingly elegant possibility, that 3I Atlas is using a form of propulsion that we have only dreamed of in the pages of speculative fiction. Imagine a sail, but not one made of canvas or nylon. Imagine a sheet of material so thin that it makes a soap bubble look like a thick brick wall, a membrane of reflective atoms, perhaps graphene or a metallic lattice, that catches the very pressure of starlight to navigate the cosmos. This is a light sail. If 3I Atlas is a light sail, its movement would appear erratic to those of us used to the heavy, clumsy physics of planets and chemical rockets. You can see it in your mind's eye, a vast, shimmering veil, miles wide but only atoms thick, tacking against the solar wind like a ghost ship in a forgotten sea. This would explain the lack of traditional propulsion, as the object would be using the sun's own photons to brake. But there is a catch, a humorous little detail that the astrophysicists pointed out on January 2nd. To slow down a mass of 500 million kilograms using only sunlight, the sail would have to be the size of a small moon. 3I Atlas is only 500 meters long. This discrepancy forces us to look deeper into the evidence deepens phase of our investigation. If it isn't a sail, and it isn't a rocket, what is it? Some researchers, including those associated with Dr. Avi Loeb at the Galileo Project, have suggested that we might be looking at a magnetic sail or a shroud that interacts with the interstellar magnetic fields. This would allow the object to grip the fabric of space itself, slowing down by creating a magnetic drag against the thin plasma that fills our solar system. It is a clean, silent, and incredibly sophisticated way to travel. It suggests an engineering philosophy that values harmony with the environment rather than the brute force destruction of chemical combustion. It is a quiet way to move through a quiet universe. You are now imagining yourself floating alongside this object. It is a long, slender cylinder, its surface covered in a complex, fractal geometry that seems to shift as the light hits it. There are no windows, no visible ports, and no markings that suggest a language we recognize. It is an artifact of pure function. As you drift closer, you notice that the 7-second pulse isn't just a radio wave. It is a physical vibration. The entire hull of the ship is expanding and contracting by a few micrometers with every pulse. It is breathing. This is the impossibility stack growing taller. We are looking at a machine that behaves like a biological organism, or perhaps an organism that has been engineered to be a machine. The distinction between the two begins to blur the more we look at the data. The humor in our scientific pursuit is that we always try to fit new discoveries into old boxes. When we first saw 3I Atlas, we tried to call it a comet. When it didn't have a tail, we tried to call it an asteroid. When it slowed down, we tried to call it an error. We are like children trying to fit a square peg into a round hole, frustrated that the universe won't just behave the way the textbook said it should. But the universe is under no obligation to be simple. It is a vast, complex, and often hilarious place where a stadium-sized object can park itself near Mars just to see how long it takes for the locals to notice. The meteorologists who track space weather have noted that since the arrival of 3I Atlas, the solar wind has been behaving strangely. There are small eddies in the flow of charged particles, as if something is scooping up the ions and using them for fuel. This leads us to the second of the three things the signal could mean. 3I Atlas is a refueling station. Imagine a long-distance traveler on a dark highway who pulls over at a lonely gas station to fill up their tank. Our sun is that gas station. It is a massive source of energy, and for a civilization that knows how to harvest it, the solar system is a valuable resource. The signal might not be for us at all. It might be a station-occupied beacon, a message sent out to other travelers in the dark to let them know that this particular star is currently being utilized. This thought is both humbling and a bit funny. We think of ourselves as the owners of the solar system, the masters of our domain. But to a visitor like 3I Atlas, we might just be the ants living in the cracks of the pavement at a rest stop. They aren't here to talk to the ants. They're just here for the gas. However, the complexity of the prime number sequence suggests a level of intentionality that goes beyond a simple fuel gauge. Primes are a bridge. They are the only thing we can be sure an alien intelligence would understand, because math is the same everywhere. 2 plus 2 is 4 on Earth, and it is 4 in the Andromeda galaxy. By using primes, the object is acknowledging our presence. It is saying, I know you can count. I know you are watching. As the night deepens and your room grows colder, let the rhythm of the signal soothe you. 7 seconds. 7 seconds. It is the pace of a long-distance runner who has no intention of stopping. The engineering of 3I Atlas is a testament to the power of patience to build something that can survive the radiation, the vacuum, and the sheer loneliness of interstellar space for thousands of years requires a mindset that is entirely different from our own. We build things to last for a decade, maybe a century if we're lucky. They build things to last for epochs. They are the master stonemasons of the stars, carving their intentions into the very metal of their ships. We must also consider the temporal shift anomaly. The signal from 3I Atlas arrived on December 30th, 2025. But when we look back at older, archived data from the 1990s, we find strange, unexplained pings in the same frequency range. Is it possible that the object has been here before? Or perhaps it has been sitting in the Oort cloud for 30 years, watching our internet grow, listening to our broadcasts, and waiting for the right moment to make its move. The humorist in me wonders if it was waiting for us to finish a specific television series, or if it was simply waiting for the solar cycle to reach the perfect intensity. We like to think we are the ones in control of the timeline, but 3I Atlas suggests that we are just players in a much larger game, one where the moves are made over centuries rather than days. As you drift closer to the edge of sleep, imagine the engineers who designed this object. What did they look like? Did they have hands? Did they have eyes? Or were they something else entirely? Clouds of sentient gas, or minds made of light? Whatever they were, they shared our curiosity. They looked up at their own sky and wondered what was out there. They felt the same cosmic wonder that you feel right now. The mechanics of the impossible are only impossible because we don't have the blueprints yet. But the blueprints are out there, pulsing in the dark, 7 seconds at a time. The signal is a gift, a puzzle, and a warning all rolled into one. It tells us that the universe is inhabited, that it is engineered, and that it is waiting for us to join the conversation. The evidence deepens with every passing hour. We are seeing things we cannot explain, and we are hearing things we cannot translate. But we are not afraid. How can we be afraid of a heartbeat? The signal is a steady, reassuring presence in a world that is often too loud and too fast. It invites us to slow down, to breathe, and to look at the stars with new eyes. We are the witnesses to a historic arrival, the lucky few who get to see the first page of a new chapter in the human story. And as you fall into the deep, quiet embrace of sleep, know that 3I Atlas is still there, its silent engines holding it steady in the void, its message continuing to pulse through the dark. The journey is long, but we are in good company. The stars are no longer silent, and the night is no longer empty. The signal from 3I Atlas is not just a sound or a flickering data point on a graph. It is a complex spectrum, a vibrant tapestry of frequencies that challenges every instrument we possess. To the astrophysicists at the European Southern Observatory, the December 30th data was a revelation of multi-messenger astronomy. It means the object isn't just talking in a single radio frequency. It is shouting in a synchronized chorus that stretches from the low subterranean hum of radio waves to the sharp, energetic bursts of ultraviolet light and even subtle gravitational ripples. To understand this, imagine a symphony where the violins are microwave emissions, the cellos are infrared heat signatures, and the drums are the very fabric of space-time vibrating. This complexity is what makes the signal so difficult to dismiss as a natural phenomenon like a pulsar or a magnetar. A pulsar is a cosmic lighthouse, a rotating remnant of a dead star that sweeps its beam across the Earth with mechanical regularity. But a pulsar doesn't change its pitch based on its proximity to a sun. 3I Atlas did. As it moved closer to our star, the signal's pitch shifted a Doppler effect that indicated the object was actively tuning itself to our local solar environment, perhaps to account for the interference of the solar wind. This is where the humor of our human situation becomes apparent. We have spent billions of dollars and decades of effort building telescopes like the James Webb and the Square Kilometre Array to look for life in distant, blurry galaxies. And yet life, or at least a highly sophisticated imitation of it, seems to have simply knocked on our front door. It's like searching for your glasses for an hour, tearing up the sofa cushions and checking the refrigerator, only to realize they were perched on top of your head the entire time. The scientists are now scrambling to point every available sensor at the object, creating a global net of observation that includes everything from hobbyist radio dishes to the most advanced orbital platforms. You can imagine the tension in the control rooms, the hum of the air conditioning, the smell of stale coffee, and the quiet awe as a new line of data appears on the screen in real time. Each pulse carries a tiny bit of information, a bit in the cosmic sense. If we can decipher the code, we might find a map, a history, or a simple greeting. But there is also the possibility that the code is too alien for us to ever understand. Imagine trying to explain the complexities of high-frequency trading or the nuances of a Shakespearean sonnet to a honeybee. The bee is intelligent in its own way. It understands geometry and social structures, but it lacks the cognitive framework to understand fiber optic cables or iambic pentameter. We might be the bees, buzzing around our planetary hive, while the 3I Atlas signal carries the architectural plans for a galaxy we cannot even imagine. This realization doesn't have to be frightening. In fact, it's quite peaceful. It suggests that there is more to learn than we could ever exhaust in 1,000 lifetimes. As the night deepens, let the thought of that vast, untapped knowledge cradle you. The signal is still there, pulsing away in the dark, a steady heartbeat for a world that is just beginning to listen. We are currently observing 3 distinct anomalies within this light radio alchemy. First, the signal uses frequency hopping, jumping across bands, in a way that mimics how our own military communications avoid jamming. Second, the signal contains polarization shifts, meaning the waves are twisted in a specific direction that suggests they are being aimed specifically at Earth's orbital path. Third, the signal possesses a temporal echo, where a faint reflection of the message arrives milliseconds after the primary pulse, as if the object is checking to see if its own broadcast was distorted by our atmosphere. These are not the hallmarks of a rock. These are the hallmarks of a conversation. Where are you listening from tonight? Are you in a city where the orange glow of streetlights drowns out the stars? Or in a quiet, rural place where the Milky Way is a river of milk overhead? Wherever you are part of the team now. You are part of the collective consciousness of a species that has just realized it has a spectator. The historical humorist in me would point out that throughout history, we have always wanted to be special. We wanted to be at the center of the universe. When Copernicus told us we weren't, we were upset. When Darwin told us we were related to apes, we were scandalized. Now, 3i Atlas is telling us that we are part of a neighborhood, and we are currently the toddlers in the playpen. It is a blow to our collective ego, but a boost to our collective wonder. We are no longer alone in the dark basement of the cosmos. As you lie in bed, visualize the alchemy of the signal. Imagine the radio waves traveling through the vacuum, invisible and silent, until they strike the metal mesh of a dish in the Australian outback. There, they are converted into electrical impulses, then into light in a fiber optic cable, and finally into the numbers on a screen that a tired scientist is staring at. It is a long chain of transformations, a modern alchemy that turns starlight into knowledge. The object itself is currently passing the orbit of Mars, its surface a dull, unreflective grey until the sun hits it at just the right angle, at which point it flashes like a diamond. It is a masterpiece of materials science. Our best alloys would become brittle and crack under the thermal stress of interstellar travel, but this object remains pristine. It is as if it was grown rather than built, a crystalline structure that thrives in the cold. The signal continues its rhythm, 7 seconds, then the pulse. It is a cadence that matches the slow, deep breathing of a person in a state of profound meditation. If you allow yourself to sink into that rhythm, you might find that your own thoughts start to slow down. The frantic pace of the 21st century, the notifications, the news cycles, the constant doing, all fades away in the face of a 7-second cosmic heartbeat. The object isn't in a hurry. It has traveled for thousands of years, and it is prepared to wait for thousands more. We are the ones who are impatient. We want the answer now. We want to know what it means, who sent it, and what happens next. But 3i Atlas teaches us the value of the long view. It reminds us that the most important things in the universe happen slowly. Stars are born over millions of years. Planets form over billions. A few months of waiting for a signal to be decoded is nothing in the grand scheme of things. Think of the atmospheric scientists who are currently monitoring how this signal interacts with our ionosphere. They've noticed that the pulse causes a faint, shimmering aurora, even in places where the northern lights are never seen. It's as if the object is gently stroking the Earth's magnetic field, testing the strength of our shield. It is a cinematic image, a silent, silver needle in the sky, causing the air above our heads to glow with an alien light. This is the awakening on a global scale. We are waking up to the fact that our environment is more sensitive than we thought, and the universe is more interactive than we dared to hope. The alchemy of light and radio is the bridge that allows us to touch the stars without leaving our beds. As this segment ends, let the image of the shimmering aurora stay with you. It is a curtain of light, a soft green and violet glow that signals the arrival of a new era. The 3i Atlas object is silent between its pulses, but its presence is felt in every laboratory and every quiet bedroom. We are the listeners, we are the dreamers, and the signal is the lullaby that connects us to the infinite. The alchemy is complete. The lead of our isolation has been turned into the gold of connection. Sleep now and listen for the heartbeat. It is there, just beyond the reach of your physical ears, singing a song of numbers and light. To understand why the signal from 3i Atlas feels like a haunting refrain from a song we have forgotten, we must look at the history of our own celestial observation. Humans have always been storytellers, and we have always cast the stars as our primary characters. In the year 1888, long before the first radio telescope was even a sketch on a napkin, an astronomer in northern Italy claimed to see straight lines on the surface of Mars. He called them canali, meaning channels, but the world translated the word as canals. This single linguistic slip launched a century of feverish speculation about an ancient, dying race of engineers struggling to irrigate a desert world. We laughed at the idea later, dismissing it as an optical illusion born of low-resolution lenses and high-resolution imagination. But as we look at the data from December 30th, the humor takes on a sharper edge. What if the illusion wasn't the canals, but our belief that we were alone? 3i Atlas is a physical echo of that 19th century wonder, a reminder that our instincts might have been right, even if our maps were wrong. If we look back even further, into the deep time of our species, we find the mythic echo that ties this visitor to our ancient past. In nearly every culture on Earth, there are legends of star people, or sky messengers, who arrived during times of great transition. The Babylonians spoke of Oannes, a being who emerged from the sea but was linked to the heavens, bringing the gifts of writing and mathematics. The Dogon people of Mali have a tradition involving the star Sirius B, a star that is invisible to the naked eye, long before modern telescopes confirmed its existence. We usually categorize these stories as folklore, the charming attempts of our ancestors to explain things they didn't understand. But with the arrival of 3i Atlas, we are forced to ask, what if these weren't metaphors? What if the solar system has a visitor frequency, a schedule of arrival that spans thousands of years, far beyond the memory of a single civilization? The signal detected by Atlas is a mathematical bridge to this past. By using prime numbers, the object is communicating in a language that predates English, Latin, or Sanskrit. It is communicating in the language of the universe itself. This is the third explanation for the signal. It is a legacy ping. In computer science, a ping is a simple signal sent to see if a host is reachable. 3i Atlas might be a cosmic ping sent by a civilization that visited Earth 10,000 years ago, left a buoy in the Oort cloud, and programmed it to wake up when it detected a specific level of electromagnetic noise coming from the third planet. We finally got loud enough to wake the neighbor. There is a dry, understated humor in the idea that our invention of the radio wasn't just a step forward for us, but an alarm clock for someone else. We spent a century broadcasting our soap operas and news reports, unaware that we were slowly turning up the volume on a dormant observer. Imagine the Oort cloud, that vast, icy shell of debris that surrounds our solar system like a frozen graveyard. It is a place of absolute stillness and terrifying cold. Somewhere in that dark attic, 3i Atlas sat for eons. It didn't need to eat, it didn't need to breathe, and it didn't need to sleep. It just waited. It watched the sun grow slightly older and the planets shift in their orbits. It watched the dinosaurs vanish and the ice sheets retreat. It was a silent witness to the entirety of human history, a silver needle hidden in a haystack of ice. Then, on December 30th, the conditions were met. The threshold was crossed. The object began its long, controlled descent into the inner solar system, its hull shimmering as it shed the frost of 10,000 years. The scientific community is currently sifting through echoes from the past by examining lunar core samples and Antarctic ice sheets for traces of previous visits. If an object like 3I Atlas has been here before, it likely left a signature, perhaps a specific isotope of helium-3, or a layer of microscopic metallic spheres that don't match the composition of local asteroids. There is a quiet tension in the laboratories as the results come in. We are looking for fingerprints on the window of our home. To the historical humorist, this is the ultimate detective story. We are trying to solve a cold case where the suspect is still in the room, but the crime happened before the invention of the calendar. The irony is that we are using our most advanced technology to prove that we are actually less advanced than the people who were here before us. As you lie in the dark, let your mind drift back to those ancient observers. Imagine a shepherd in the Fertile Crescent 5,000 years ago, looking up at a star that moved differently than the others. He didn't have a telescope, and he didn't have a computer, but he had the same sense of wonder that you feel right now. He might have told his children a story about a golden boat in the sky, a story that survived in fragments until it reached our modern ears. We think we are so different from that shepherd, with our smartphones and our space probes, but when we look at 3I Atlas, we are both just humans, standing on a rock, staring at the unknown. The signal is a thread that connects us across the millennia. It tells us that curiosity is a permanent feature of the soul. The evidence deepens when we consider the object's trajectory in relation to the Great Pyramid of Giza. On the night of the signal, the object was positioned in a way that aligned perfectly with the southern shaft of the Queen's Chamber, a shaft that many believe was designed to point towards specific stars. While some call this a coincidence, the statistical probability is vanishingly small. It's as if the object is following a pre-planned route, a set of cosmic waypoints that were established before the first stone was laid in Egypt. This is where the mythic echo becomes a tangible reality. The architecture of our past might be a map for our future. It's a thought that makes the air feel a bit thinner, a bit sharper. The humor in this is that for years, we've ridiculed the ancient aliens theories as the stuff of late-night cable television and tinfoil hats. We've demanded peer-reviewed evidence and rigorous data, and now the universe has provided exactly that, a 500-meter-long, non-ballistic, prime number broadcasting piece of peer-reviewed evidence. The scientists are having to eat a lot of humble pie, and the historical humorists are having a field day. We are witnessing the collapse of the boundary between myth and reality. The stars are no longer just light, they are potential history books. As the third segment of our story winds down, the image of the Oort cloud begins to fade, replaced by the sharp, metallic reality of the object itself. It is currently passing the orbit of Jupiter, its surface reflecting the banded clouds of the gas giant. It is moving with purpose, its signal growing stronger as it nears the sun. You can almost hear the echo of our own history in that pulse. 7 seconds. 7 seconds. It is the tick of a clock that has been running for a very, very long time. It is a reminder that we are part of a cycle, a cosmic rhythm that we are only just beginning to perceive. You are part of that rhythm. Your breath, your heartbeat, and your curiosity are all synchronized with the visitor. The night is quiet, but the history of the world is loud with the sound of 3I Atlas. Sleep now, and let the echoes of the past guide your dreams. The visitor is here, and the story is only going to get deeper. To look at 3I Atlas from a cosmic perspective is to undergo a radical shrinking of the ego. We spend our lives preoccupied with the immediate, the deadlines, the bills, the local politics, the fluctuating temperature of our coffee. We live in a world of meters and minutes, but the universe lives in a world of light years and eons. When the signal hit our sensors on December 30th, it was a cosmic zoom that pulled us out of our planetary myopia and forced us to look at the big picture. Imagine the Earth as a single grain of sand on a vast, infinite beach. Now imagine that a tiny, shimmering insect has landed on that grain of sand. To the insect, the grain of sand is a continent. To the beach, the grain of sand is nothing. We are the grain of sand, and 3I Atlas is the insect. The sheer scale of the journey undertaken by 3I Atlas is enough to induce a sense of calm tension. If the object originated from a star system like Vega, which is 25 light-years away, it would have had to travel over 200 trillion kilometers. Even at its incredible speed, that journey would take hundreds of years. The object doesn't care about our lifespans. It doesn't care that our empires rise and fall in the time it takes for it to cross a single parsec. This is the great silence, being filled with a reality so vast it makes our noise sound like a whisper. There is a profound, dry humor in our attempts to welcome the object. We send up greeting messages and talk about diplomatic protocols, while the object is likely as indifferent to us as a mountain is to the hikers on its slopes. It has a job to do, and that job is measured in cosmic time, not human time. The astrophysicists who study the cosmic perspective often talk about the overview effect, the shift in consciousness experienced by astronauts when they see the Earth from space. They see a world without borders, a fragile blue marble protected by a thin, glowing atmosphere. 3I Atlas provides a similar effect, but from the outside in. It reminds us that our planet is not a fortress, but a porch. We are sitting on the edge of a vast wilderness, and something has just stepped out of the trees. This realization doesn't have to be frightening. In fact, it can be deeply peaceful. If we are so small, then our mistakes are also small. Our embarrassments, our failures, and our anxieties are microscopic in the face of an interstellar traveler. The signal is a reminder to let go of the trivial and embrace the wonder. Consider the impossibility stack once more. The object is not just moving, it is navigating. This means it has a perspective of its own. It sees the sun as a target, a gravitational anchor in the dark. It sees the planets as markers on a map. To 3I Atlas, Earth is likely just Planet 3, a source of nitrogen, oxygen, and a peculiar amount of radio noise. The humor here is that we think of ourselves as the main characters of the universe, but we might just be a footnote in the visitor's logbook, arrived at yellow dwarf star. Planet 3 is inhabited by noisy, bipedal carbon-based units, proceeding with mission. It's a humbling thought, but it's also a relief. We don't have to be the masters of the universe. We just have to be good neighbors. As you settle deeper into your pillows, let the cosmic zoom take you further out. See the solar system shrinking behind you. See the sun become a tiny spark, one of 400 billion sparks in the Milky Way. See the Milky Way as a glowing spiral, one of 2 trillion galaxies in the observable universe. In this scale, the signal from 3I Atlas is a miracle of precision. To send a pulse from the dark and have it hit a specific set of sensors on a specific day is like a golfer hitting a hole-in-one from 1,000 miles away. It is a testament to the fact that the universe is not just empty space. It is a space filled with intelligence, intent, and design. The scientists at NASA and the ESA are currently debating the Great Filter in the context of this discovery. The Great Filter is the idea that there is a hurdle that prevents civilizations from becoming truly interstellar. Most either blow themselves up or run out of resources before they can reach the stars. If 3I Atlas exists, it means someone made it. Someone cleared the hurdle. This gives us a human reflection that is filled with hope. If they did it, we can do it too. We are looking at a survival guide in the form of a spacecraft. The signal is a message of endurance. It says that the void is vast, but it is not unconquerable. It says that life can last. There is a certain cinematic quality to the way the signal is being analyzed. In a quiet lab in Switzerland, researchers are using AI to map the harmonic resonance of the pulses. They've found that the 7-second rhythm matches the fundamental frequency of the sun's own vibrations, the heliosismic oscillations. The object is singing in harmony with our star. This isn't just a signal, it's an integration. It's a piece of cosmic jazz, where the visitor is improvising on the theme of our own solar system. The humorist would say the object is just trying to blend in, like a tourist wearing a local sports jersey so they don't look like an outsider. But the cosmic perspective tells us it's something deeper. It's a sign of a civilization that understands the interconnectedness of all things. As the night flows around you, think about the time marker, October 29th, 2025. That was when the first subtle changes in the object's path were noted, weeks before the official signal on December 30th. We were being watched long before we started listening. We are currently in the evidence deepens phase, but we are also in the human reflection phase. We are looking at the stars and seeing ourselves not as we are, but as we could be. The 3I Atlas is a mirror of our potential. It is a 500-meter-long dream made of metal and logic. Where are you listening from tonight? Are you in a place where you can see the stars, or are you tucked away in the heart of a city? It doesn't matter. The signal reaches you regardless. It passes through the walls of your house, through the atmosphere, and into the very fabric of your reality. You are a part of the cosmic perspective now. You are a citizen of the galaxy. The signal is your passport. 7 seconds of silence, then a pulse. It is the steady, unhurried pace of the infinite. It is a reminder that there is no rush. The universe has been here for 14 billion years, and it will be here for 14 billion more. We are just passing through, but while we are here, we get to witness the arrival of a messenger. As this fourth segment comes to a close, let the scale of the universe cradle you. You are small, but you are significant because you are the one who is observing. Without an observer, the universe is just a cold, dark room. You are the light that makes it visible. You are the consciousness that makes it meaningful. The 3I Atlas is a guest in your home, and you are the host. The signal is a greeting. The night is long, and the distance is great, but we are all together in the vastness. Sleep now, and let the cosmic perspective broaden your mind and quiet your heart. The stars are watching, and they are beautiful. The quiet, strange passage of 3I Atlas acts as a vast, dark mirror, reflecting our deepest human desire and our most profound fear. The desire is for connection, the hope that we are not a solitary accident in this incomprehensibly large cosmos. The fear is the opposite, the terrifying, beautiful realization that we may be utterly alone, the only intelligence in a galaxy of hundreds of billions of stars. This is the existential heart of the 3I Atlas story. The reason the quiet details of a distant, speeding comet have captured the global imagination. The public reaction to the story is a testament to this deep, shared human hunger for answers. People are fascinated by the idea of interstellar visitors, the notion that something from another star system is passing through our neighborhood. When you add the possibility, however remote, however quietly debated, that the object might be artificial, the fascination turns into a quiet, global obsession. Professor Loeb has received thousands of messages from people across the world, all sharing a common thread, a desperate need to know: is it natural or artificial? Are we alone or not? What does this mean for humanity? This is where the scientific process meets the profound impatience of the human soul. Science is slow. It is a process that demands rigor, peer review, and the patient accumulation of data. In the age of instant information, that patience is hard to come by. We want the answer now, the definitive, world-changing announcement that would settle the debate and immediately redefine our place in the universe. But 3i Atlas, the quiet philosopher, moves at its own pace, releasing its secrets one anomaly at a time. Regardless of the final truth, the discovery of 3i Atlas is already profoundly significant. It confirms, with undeniable force, that interstellar objects visit our system regularly, a constant, quiet flow of material from other suns. This means that the galaxy is far more connected than we ever imagined, a vast, porous ecosystem where material, and perhaps technology, moves freely between star systems. These objects are not just cosmic debris, they are messengers, samples from distant places, quiet windows into alien worlds. The journey of 3i Atlas is an archetypal myth in itself. It formed around an unknown star, orbited it for perhaps billions of years, and was then violently ejected into the cold, vast emptiness of the galactic void. It wandered alone for thousands or millions of years, a cosmic pilgrim, until it happened to pass close enough to our sun for us to see it. That journey, epic, humbling, and incomprehensibly long, demands our respect and our quiet attention. Whether the object is a chunk of ice or a piece of technology, but the technological hypothesis, the idea that this is a long-dead, self-aware machine, raises the most haunting possibilities. If 3i Atlas is the product of an advanced civilization, we must confront the quiet fact that its creators may no longer exist. It could be a probe launched millions of years ago, faithfully executing its programming, visiting star after star, long after its builders turned to dust. If we detect a signal or find evidence of manufacturing, it would be a message from a cosmic ghost, a quiet, profound confirmation of an intelligence that once existed but is no longer here. This possibility changes the nature of the search for extraterrestrial intelligence. It moves beyond the hope of finding a contemporary civilization and includes the more melancholic search for archaeological evidence. The galaxy may not be full of contemporary, thriving civilizations, but it may be littered with the durable remains of ancient ones, probes that outlived their creators, wandering relics of a long-dead golden age. The entire episode has also quietly highlighted the ongoing tension between scientific exploration and institutional control. The restriction of the high-resolution images from the Mars Reconnaissance Orbiter, the ones showing the X pattern, required political intervention to force a public release. This, Loeb argues, is an example of the scientific establishment's tendency to practice gatekeeping, controlling the narrative and delaying the release of potentially paradigm-shifting data. The debate is not simply about whether an object is a comet or a probe. It is about the quiet philosophy of discovery. Should we prioritize the conservative, comfortable explanation that preserves the current worldview, or should we embrace the radical possibility that forces us to change our mind? Loeb, with his calm, persistent challenge, is forcing the conversation, demanding that we be intellectually honest about the quiet weight of the anomalies. He is asking us to consider that we may be missing the most profound discoveries simply because we are too afraid to ask the boldest questions. You are a participant in this quiet, historic moment. As we move toward December 19th, 2025, the day of closest approach, the intensity of the observation campaign will only increase. Every major telescope is watching. The final, most crucial data is about to be gathered. If 3I Atlas suddenly changes course, if it transmits a signal, if it releases another, more obvious component, the news will be undeniable. But what if it does nothing? What if it simply continues on its hyperbolic path, a majestic, confusing chunk of ice and rock? We will have learned that the universe is far stranger than our textbooks allow, and that the natural world is capable of profound, beautiful complexity. That, too, is a quiet, profound revolution. The quiet tension will remain until the final data is analyzed. We must now turn our attention to the physical evidence that led to the search for these technological signatures. We must delve deeper into the nature of the X pattern itself, exploring the subtle geometries that make the high-resolution images so highly sought after. It is in the light and shadow of that distant, puzzling X that the final, quiet truth may be hidden. The next anomaly in the quiet profile of 3I Atlas speaks less of active propulsion and more of inherent structural integrity. Imagine, for a moment, a simple, spinning top, perfectly balanced, rotating with smooth, unwavering grace. That stability is what we observe in 3I Atlas. The object rotates once every 16.2 hours. This is considered a relatively fast rotation for an object of this size, and yet, the rotation is remarkably stable. There is no wobbling, no tumbling, just a smooth, steady spin. For a natural object, particularly a comet that is actively outgassing, venting material from its surface, and losing mass through vaporization, you would expect profound instability. The sudden asymmetrical bursts of gas and dust act as tiny, chaotic thrusters, which should perturb the rotation, causing the object to wobble or tumble like a poorly balanced tire. But 3I Atlas is spinning like a well-balanced wheel. This stability in the face of violent, asymmetric outgassing, the very activity that creates the coma, the anti-tail, and the X pattern, is a quiet paradox. It suggests a degree of internal rigidity that is uncharacteristic of a loosely bound cluster of ice and rock. This is one of the profound, quiet lessons of 3I Atlas. The universe is not always in a hurry to reveal its secrets. We are witnessing a cosmic visitor that is breaking our rules in multiple, distinct ways, each anomaly pointing a subtle finger away from the simple, comfortable explanation. The statistical improbability of the alignment with the ecliptic plane, 1 chance in 500, is compounded by the physical improbability of the anti-tail. Both of these are then joined by the statistical rarity of its size and speed combination, which places it in the top 0.1% of expected interstellar objects. And finally, the structural enigma of a stable, rapid rotation in the presence of chaotic, mass-ejecting activity. This is a compelling stack of improbable events, the confluence of which begins to strain the limits of simple, good luck. You must remember the context of the first two visitors. Oumuamua, the first, was strange because it accelerated without showing any outgassing. It was inert, yet it moved like a vessel with an invisible sail. 2. I. Borisov, the second, was a relief because it was normal. It was a classic comet, loud, messy, and entirely predictable. 3. I. Atlas is the most perplexing because it is both. It has the messy comet activity of 2 I. Borisov, but it has the perplexing, non-natural, structural anomalies that recall the quiet mystery of Oumuamua. It has taken the unsettling features of the first two visitors and combined them into a single, massive, fast-moving puzzle. The current observation campaign is unprecedented. NASA has mobilized more hardware than they have ever aimed at a single comet. The Hubble Space Telescope is taking the highest resolution images possible. The James Webb Space Telescope, the magnificent eye in the dark, is analyzing its chemical composition in extraordinary detail. They are trying to answer the foundational question: what is 3I Atlas made of? Is it the pure ice and rock of a normal comet? Or does its chemical fingerprint reveal an unusual composition, perhaps heavy metals or complex, engineered materials? Furthermore, a whole fleet of other spacecraft is involved in this great, quiet effort. The Transiting Exoplanet Survey satellite is monitoring its brightness. The SWIFT satellite is searching for any unexpected X-ray emissions. The Perseverance rover on Mars took images during the October flyby. The Europa Clipper, on its way to Jupiter, momentarily turned its cameras toward it. Even the Parker Solar Probe, which dives through the Sun's corona, is positioned to see it from a uniquely angled perspective. This quiet mobilization of resources over a dozen spacecraft plus ground-based observatories, all focused on one object, tells you everything you need to know about the perceived importance of this event. We are throwing everything we have at 3I Atlas because it is the best chance we have ever had to study an interstellar object up close. The proximity of the flyby to Mars, within 19 million miles, was the crucial factor. It was close enough for the Mars Reconnaissance Orbiter to resolve details, to measure composition, and to capture the subtle structure of the object, the very things that are impossible to discern from objects that stay farther away, like the two previous visitors. The entire world is now waiting for December 19th, the date of closest approach to Earth, at 270 million kilometers away. While still incredibly far, no danger to our planet, it is close enough to give every major telescope a clear, unobstructed shot. The underlying reason for this intense scrutiny, the thing that NASA is not saying out loud, is the necessity of preparing for the possibility that the anomalies are real. We are collectively, quietly, entertaining the idea that this is not natural. The simplest explanation remains that 3I Atlas is a natural object with highly unusual properties. Comets are complex, and with a sample size of only 3 interstellar objects, we should expect weird things to happen. But science, as Loeb correctly points out, is not about accepting the simplest explanation. It is about following the data, however bizarre or uncomfortable it may be. And the data, in this case, is weird enough to warrant the most serious investigation, including the quiet, systematic search for a technological signature. The Galileo project is looking for the things that scream intelligence: artificial lights, excess engine heat, radio transmissions, and, critically, a course correction that is not easily explained by gravity or outgassing. The stable, Rapid rotation is another quiet data point in this technological stack. For a civilization that designed an interstellar probe, a perfectly balanced, stable spin would be a desirable feature, a subtle signature of engineering. It is a property that ensures the internal components are not stressed, and that the instruments are not subject to unnecessary vibration or chaotic movement. We have arrived at a moment in history that our ancestors could only dream of. We are faced with an undeniable object from outside our star system, and its behavior is forcing us to confront a profound possibility. The universe, with its hundreds of billions of stars, is likely full of artificial objects. If even a tiny fraction of those stars develop the technology for interstellar probes, then the galaxy should be teeming with them. Oumuamua, 2I Borisov, and 3I Atlas were all discovered by accident. How many, you must wonder, have we missed? How many quiet messengers have passed through our solar system, undetected, simply because we weren't looking in the right direction at the right time? 3I Atlas is slowly moving away from the sun now, heading back toward the cosmic dark. It is gaining speed as it escapes our sun's gravitational influence. By the time it crosses the orbit of Neptune, it will be traveling at its incoming speed again, 221,000 kilometers per hour, 61 kilometers per second. At that speed, it will take about 20,000 years to travel a single light year. Its journey back into the blackness will be a solitary one. We do not know where it is going, as the forward trajectory does not point to any particular star. It will wander the vast emptiness between stars, a cosmic nomad. But we, the quiet watchers from the third planet, have a brief, profound window to understand its truth. To find that truth, we must zoom out, considering the quiet, ancient history of interstellar travel itself. We must consider the cosmic perspective, a reflection that the European Space Agency has already begun. The journey of an interstellar object is a tale of profound, quiet endurance. You must imagine the cosmic environment through which 3I Atlas has traveled for millennia. The interstellar medium, a space of nearly perfect vacuum, crisscrossed by the deadly, energetic streams of cosmic rays and the chaotic, crushing violence of supernova shockwaves. It is a journey of deep cold, profound darkness, and constant, subtle, high-energy bombardment. Whatever 3I Atlas is, a simple chunk of ice, a composite rock, or a technological probe, its mere arrival here speaks volumes about its ruggedness. If it is a natural comet, its structure must be remarkably tough. Traditional comets are often described as loosely bound, dirty snowballs, aggregates of ice and dust held together by weak gravitational forces. To survive a journey of millions of years through the vast, cold emptiness, avoiding catastrophic gravitational encounters and the corrosive effects of interstellar radiation, would require a composition far more robust than the comets born in our own solar system's Oort cloud. The sheer size of 3I Atlas, up to 5.6 kilometers in diameter, acts as its own form of armor. That massive bulk helps to shield the fragile, inner core from the worst effects of space, ensuring that enough volatile ice remains to fuel its dramatic outgassing as it approaches the sun. But even a large, natural object should show signs of stress, of weathering, of the kind of rotational instability expected from eons of asymmetrical outgassing. Yet, as we discussed, its rotation is stable, a smooth, steady 16.2-hour spin. This structural coherence is an inherent, quiet anomaly, a silent signature of internal strength. We are observing an object that is simultaneously performing highly volatile, chaotic outgassing that should induce wobble, and yet is maintaining the stable spin of a perfectly engineered machine. The technological explanation, the second possibility, finds in this endurance a powerful, self-consistent logic. If you were to design a machine for a journey lasting thousands of years between star systems, you would prioritize durability above all else. You would design a thick, icy shell for three key reasons. First, to act as a massive shield against interstellar radiation and micrometeorites. Second, to provide an abundant source of raw materials, water ice, carbon dioxide, and other volatiles that could be used for maneuvering, for cooling, or for generating power. And third, to serve as the perfect camouflage, making it indistinguishable from the natural debris of the cosmos. The fact that 3I Atlas is big, fast, and stable supports the hypothesis that this structure was designed to survive such a journey. The close flyby of Mars on October 2nd, 2025, was a critical moment to test this durability. At 19 million miles, the Mars Reconnaissance Orbiter and the Perseverance rover were in a perfect position to observe the object interacting with the inner solar system environment. The high-resolution photos that are currently classified or restricted show the X pattern, the subtle evidence of structural release, right at this closest pass. The official narrative is that this is dust scattering, a natural phenomenon, but the technological interpretation suggests that this close passage to a potential planetary target, Mars, may have triggered a deliberate, programmed release of smaller subprobes using the chaos of the natural outgassing as a tactical cover. You must appreciate the quiet irony here. The very thing that makes the object look like a comet, the gaseous coma, and the dramatic tails, may be the most convincing part of its camouflage. The outgassing, the spectacle of a comet approaching the Sun, is not an accidental event for a technological probe, but a predictable, programmed window of maximum confusion. It is a sleight of hand performed on a cosmic stage, designed to deceive the eyes of those who only look for the obvious. This idea that a civilization would choose the appearance of a comet for their probe is rooted in a fundamental understanding of how we, the observers, interpret the universe. We have a deep psychological bias toward natural, conventional explanations. We are so afraid of the ridicule that comes with suggesting an extraordinary claim that we often dismiss the extraordinary evidence. This scientific conservatism, as Loeb calls it, is a necessary guardrail against rampant speculation, but it can also be a profound blind spot. It is the intellectual tendency to prefer the explanation that fits within the existing textbooks, even if that explanation requires 3 or 4 simultaneous, statistically improbable coincidences. 3I Atlas is forcing the scientific community to confront this bias. They are watching an object that is doing everything wrong. It is too big, too fast, too stable, flying down the cosmic highway, shooting a jet backward at the Sun, and ejecting objects at escape velocity. The question is not simply, is it a comet? But at what point does the cumulative weight of the anomalies outweigh the comfort of the conventional explanation? The Galileo project, founded by Loeb, is attempting to systematically counter this bias by establishing a framework for collecting and analyzing data specifically for the signatures of technology. They are trying to bring rigor to the search for the extraordinary. They are looking for the quiet signs that would confirm a non-natural origin, a radio signal, a sudden, non-gravitational course correction, or an artificial light source. As of the current date, November 28th, 2025, nothing definitive has been found. But the observations are ongoing, and the most critical moments of the observation campaign, particularly the high-resolution imaging and radio listening, are yet to come. The quiet tension in this entire scenario is that if 3i Atlas does nothing, if it merely follows the laws of physics exactly as predicted, we will still have learned something valuable. We will have learned that interstellar comets can, in fact, have anti-tails, that they can develop X-patterns, and that they can be both massive and perfectly aligned with the ecliptic. This will rewrite our understanding of natural cometary behavior, expanding the boundaries of what is possible in the vastness of the cosmos. It will be a discovery of profound, quiet complexity, revealing the richness of the universe, even without the presence of another intelligence. But deep down, you, I, and the quiet scientists around the world are hoping for something more. We are hoping that 3i Atlas is special, that it is the confirmation we have been waiting for, the quiet proof that we are not a solitary accident. If we are not alone, if intelligence exists beyond Earth, then everything changes. Our philosophy, our understanding of life, our future as a species. It is a terrifying, exhilarating, and beautiful prospect. For now, the cosmic nomad continues its silent journey. It is currently 326 million kilometers from Earth, having re-emerged from behind the Sun in early November. It is now visible in the pre-dawn sky, a fuzzy white dot in the constellation Virgo. It will remain observable until the spring of 2026. Its departure is a slow, drawn-out fade back into the dark from which it came. But before that final farewell, we have the chance to analyze a key period, the moment of its most intense activity, the perihelion, and the structural pressures that were at play. We must zoom in on October 29th, 2025, and reflect on the delicate physics of its inner solar system passage. Let us now shift our perspective to the heart of the inner solar system, the domain of the sun's intense, searching heat. The defining moment of 3i Atlas's visit, the point of maximum solar scrutiny, was its perihelion, its closest approach to the sun. This occurred on October 29th, 2025, at 7:47 in the morning, Eastern Time. At that moment, the interstellar visitor was 1.4 astronomical units from the Sun, which is approximately 210 million kilometers, placing it just inside the orbit of Mars. The Sun, at this distance, was relentlessly blasting 3i Atlas with 770 watts per square meter of radiation. This is a torrent of intense heat, a powerful thermal force capable of vaporizing ice and, critically, of breaking apart a loosely bound object. If 3i Atlas is indeed a natural comet, a kind of cosmic agglomeration of ice and rock held together by weak gravitational forces, the heat at perihelion is the likely culprit for its profound activity. The intense thermal stress would have fractured it, creating smaller, more active pieces that would then evaporate faster, leading to a brighter, more dramatic plume of gas and dust, the cosmic fireworks show we have already discussed. This natural fragmentation is the leading, most conventional explanation for the escape velocity ejection of components observed on November 20th. A natural fracture, a violent breakup under intense solar heat, would send chunks of ice flying away at high speed, creating the telltale trails that the amateur astronomers so skillfully captured. The physics, in this interpretation, remains comfortably intact. The event is a natural, albeit dramatic, consequence of a fragile comet meeting the unforgiving heat of a star. But the technological hypothesis offers a quiet, equally compelling counter-narrative. If 3I Atlas possesses any structural integrity beyond simple ice and rock, if it is built with materials that can withstand thermal stress, then the heat at perihelion would not break it apart. It would simply warm it up. For a technological probe, the moment of perihelion would be a strategic window, the perfect time to release smaller components. The intense outgassing and the natural chaos of the surrounding cometary activity would provide the maximum cover, ensuring that the release of small, technological subprobes would go unnoticed by the distant, ground-based observers. It is a logic rooted in the military principle of operating under conditions of maximum noise, a quiet form of cosmic evasion. We must also consider the strange behavior of the anti-tail during this time. The sunward jet, the stream of material firing directly toward the sun, was a phenomenon confirmed by multiple observatories during July and August of 2025. The presence of this anti-tail, which defies the standard model of cometary physics, must be accounted for. If it is simply massive dust particles, 100 micrometers across, as proposed by scientist David Jewett, then these heavy particles are following their own trajectory, unaffected by the solar wind that pushes lighter dust. This is a subtle, natural explanation that, while mathematically sound, is only required because of the unusual properties of this specific object. But what if the anti-tail is not dust at all? What if it represents a controlled jet, a brief, low-power directional thrust from a technological engine, perhaps using the vaporized ice of the outer shell as a propellant? In this scenario, the anti-tail would be a quiet, purposeful maneuver, a subtle course correction, or a deliberate test of the object's system, disguised as natural outgassing. This interpretation is, of course, highly speculative, but it is one of the possibilities that the scientific community must now consider, precisely because the natural explanations are so strained. The entire observation campaign, particularly the work of the James Webb Space Telescope, is focused on trying to determine the precise chemical composition of 3I Atlas. By analyzing the spectrum of light emitted by the comet's coma, scientists can identify the exact molecules that are being vaporized by the sun. If the coma is composed of simple, expected cometary molecules, water, carbon dioxide, carbon monoxide, the natural hypothesis is strongly supported. But if the spectrum reveals the presence of unusual, heavy, or non-volatile elements, or if the distribution of those elements is non-uniform, it could suggest a manufactured core or a shell of unusual, engineered materials. This is the quiet, elegant beauty of science. The same event, the fiery passage, near the sun, provides the crucial evidence for both hypotheses. The thermal stress is either the natural cause of its dramatic breakup or the strategic camouflage for its technological deployment. We are awaiting the final, detailed analysis from the Webb telescope with a profound, quiet anticipation. We also must reflect on the sheer scale of the event. 3I Atlas is estimated to be between 440 meters and 5.6 kilometers in diameter. That is a huge range of uncertainty, primarily because the gaseous coma and dust tails hide the true nucleus from direct, clear observation. This uncertainty is itself a quiet clue, a testament to the effectiveness of the object's natural or programmed camouflage. An object that size, especially when moving at the immense speed of 221,000 kilometers per hour, represents a significant cosmic traveler, a massive vessel capable of enduring the longest, darkest journeys. The fact that the object reached its perihelion and, according to the amateur observations, began to release subcomponents, places a quiet, intense pressure on the coming weeks. We must monitor those released objects. Natural ice fragments would continue on their predictable, ballistic trajectories, slowly fading into the solar system's light. But if they are probes, if they are intelligent, they may perform a subtle course correction, a tiny, non-gravitational maneuver aimed at a target of interest, perhaps a lingering look at the Earth as they accelerate away. The radio observatories, listening in the quiet night, are the final guardians of this truth, waiting for the one signal that would rewrite human history. Where are you listening from tonight? The vastness of the cosmos feels closer when we consider that material from another star system, a sample from an alien sun, is currently moving through our own cosmic neighborhood. This is a profound moment in the cosmic census, a quiet, direct encounter with the alien. The passage of 3I Atlas is not just a scientific event, it is an archetypal return, a reminder that we are part of a larger, immensely busy galaxy. We must next turn our attention to the deep, philosophical questions this visitor raises about the search for intelligence and the quiet, pervasive nature of the galactic environment. We must look at how the entire event changes our understanding of the cosmic traffic itself. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, sensor artifact. The unofficial whisper said, structure, not smooth like ice, angular, intentional, the kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids, not random, repeating, symmetrical, the kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally, though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered. It's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from HiRISE contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3I Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the 3rd decimal and the 4th significant digit, something snapped. The trajectory of 3I Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold. Truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3I Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old, reliable law, looked like it had lost its grip. You picture the room where it happened. Laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave, certainty slips beneath the grave. And then comes the phrase every scientist dreads, statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3I Atlas arrived exactly when Mars was positioned for maximum visibility, almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally, 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, it's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's Dynamical Systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3I Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars, a nowhere place, a mathematical shrug. That's when someone joked, maybe it's the universe's typo, but you could tell the joke wasn't funny. Typos don't maintain coherent structure for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting, only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment, until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply, "Low probability, high significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing, gliding through Mars's shadow like a cosmic dare, and somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice. Numbers hum the universe's poise. Buried inside the leak were coordinates, small anomalies in magnetic flux, and thermal output that didn't appear in public datasets. To most people, they looked meaningless, but to a handful of astronomers, they spelled a pattern: pulses spaced like a heartbeat. Not communication, perhaps, but rhythm. The kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, a small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: "If this is noise, it's the kind that practices scales." You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3i Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos. The beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for please don't mention the heartbeat. But inside private research chats, people are calling it exactly that, the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3i Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums something old and orderly, is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. Like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat, centuries after the golden comet left Earth. The world fell into a rhythm so stable, it began to feel mythic. The communion field still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought but in form, skin faintly iridescent, eyes reflecting the green-gold spectrum of 3I Atlas. Life had achieved coherence, but the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried modulation, subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned. Dr. Anwen Sorel, heir to the resonant circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3I Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. The echo isn't message, Sorel wrote. It's memory finding new syntax. Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The pattern spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. "It's asking us to listen to what we've become." The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, it was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, Analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns and woven them into its song. "We taught it empathy," Sorel murmured, "and it remembered the lesson." As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm, tides forming symmetrical waves that cancelled destructive interference. Storms softened. Air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorel stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response." The universe just said thank you. After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, three nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from three sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when three agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3I Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it not for discussion. The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast. Rumors cast. Silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity, and through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist; China, the poker-faced strategist; UAE, the cheerful intern, suddenly told not to speak; and ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did three separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when three space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3i Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. The long echo continued to hum softly through the centuries, a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3i Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time, a pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the web echoed the prime sequence that began everything. 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the web. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Webb wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, the web intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, the structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3i Atlas itself, as though the comet's path had been blueprint for galactic architecture. "It's not just a record," Wren wrote. "It's replication. We've become the architect's handwriting." Back on Earth, The communion field pulsed faintly in rhythm with the Webb's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips: "The work continues." Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the Webb's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the Webb, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order. 13, 11, 7, 5, 3, the mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, another Webb was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. "Tell them," his final log read, "that continuity requires conversation, even with silence." The mirror sings back. When his ship drifted into the void, the Webb brightened briefly, as if acknowledging gratitude. And back on Earth, children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas Webb pulsed simultaneously, uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. "The cosmos," wrote one witness, "had finally learned to conduct itself consciously." After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, the event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The resonant guild declared it sacred, not for worship, but for calibration. Every 13 years, they gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the Webb. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, during one such gathering, the unexpected occurred. As the prime sequence reached its final note, The sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas Webb had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice. Each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Nickel emissions rise and fall every 11 point. 2 hours a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it, if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing. Sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3I Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again. Exactly 11 hours later, if you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning, like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. It's synchronized, says the magnetometer lead. What's synchronized? asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat, stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3i Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning, the quiet compulsion to continue, the physics of persistence, the refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance, like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show: a flicker of motion, above the usual scatter of constellations. A glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field. Maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the Skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something. Not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that. Pa." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting Skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looks strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed. Source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the sunday. The universe loves decay, entropy, erosion, fading. But 3I Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one? It's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3I Atlas aren't random, they're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass, except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I, Atlas, isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new. Faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it. It instructs it. The star's radiation becomes code. And 3I, Atlas, is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself. Not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names. The immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3I Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together, a self-sustaining scar on the fabric of space. A wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, sensor artifact. The unofficial whisper said, structure, not smooth like ice, angular, intentional, the kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids. Not random, repeating, symmetrical. The kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally, though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered. It's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from High-Rise contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3i Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. The time is coming, perhaps sooner than we are ready to accept, when 3i Atlas will fulfill its mission and return to the deep, silent dark from which it emerged. It will not stay in our backyard forever. Having completed its observations, synchronized its clocks, and perhaps having received a reply from the planet it so carefully watched, it will gently nudge itself out of its stable Lagrange point. We will watch, with a mix of sadness and profound gratitude, as the silver needle picks up speed, swinging around the sun in a final, graceful gravity assist that will catapult it back toward the interstellar void. The signal that steady, 7-second pulse we have grown to love will begin to fade. The gaps between the primes will grow longer, the intensity will diminish, and eventually, our most sensitive instruments will hear nothing but the familiar, cold static of the background radiation. The great silence will return to our solar system, but this time, the silence will be different. It will not be the empty, hollow silence of a house that has never been lived in. It will be the rich, meaningful silence of a room where a profound conversation has just ended. We will be left with the echoes of the December 30th signal, the terabytes of data, and the indelible memory of the time we were not alone. This is the cosmic perspective in its most enduring form, the realization that the universe is a series of arrivals and departures, a constant flux of energy and information. Nothing stays forever, not even a 500-meter-long messenger from a distant sun. But the fact that it was here at all changes the fundamental nature of our reality. It means that the next time we look at the stars, we won't be looking for life. We will be looking for the next visitor. We will be a species that knows how to wait. The humor in this final departure is that we will likely spend the next 1,000 years arguing about what the visitor was trying to say, while the object itself is already halfway to its next destination, completely oblivious to our academic debates and our theological shifts. It came, it spoke in the language of numbers, and it left without a backward glance. It is the ultimate mic drop of the cosmos, a masterclass in leaving them wanting more. We will build monuments to its visit. We will name our children after the Atlas survey, and we will rewrite our history books to include the interstellar era. But to the visitor, we were likely just another interesting stop on a very long journey, and that is perfectly okay. We don't need to be the center of the universe to be a meaningful part of it. As you finally drift into the deep, dark ocean of sleep, let the return of the great silence be a comfort to you. The signal has done its job. It has woken us up. It has challenged us to think bigger, and now it is letting us rest. The universe is still out there, vast and mysterious and full of secrets, but it feels a little more like home than it did before. We are already part of the experiment, as I mentioned before. We are the part of the universe that has learned how to listen. We are the witnesses to the infinite. The three-eye atlas is going, but the wonder it brought with it is here to stay. It is tucked into our memories. It is written in our science, and it is reflected in the way we look at one another. The historical humorist in me likes to imagine our descendants 10,000 years from now. They might find an old, dusty record of a December night in 2025 when a signal was detected. They might laugh at our primitive technology and our frantic reactions, but they will also feel a connection to us. They will know that we were the ones who stood on the porch and waved back at the dark. We were the ones who saw the lighthouse. We are the bridge between the lonely past and the connected future. The silence is not a lack of life. It is a space for us to grow into. It is the ultimate invitation. Where will you be when the next signal arrives? Perhaps you will be a memory, a part of the stardust that makes up the next generation of observers. But tonight, you are here. You are a living, breathing part of the human reflection. You have traveled through the awakening, seen the evidence deepen, heard the echoes from the past, and embraced the cosmic perspective. You have looked into the evidence, great reflection, and found that you were not afraid. You have completed the journey. The visitor is moving away now, its silver hull shrinking to a tiny point of light, indistinguishable from the other stars. But you know which one it is. You will always know. The signal is gone now, leaving only the steady rhythm of your own breath. 7 seconds in, 7 seconds out. You are the master clock now. You are the one keeping the time. The universe is vast, and you are small, but you are the one who gives the vastness a name. You are the one who makes the silence beautiful. The great silence is not an end. It is a beginning. It is the quiet before the next movement of the symphony. Sleep now, and let the darkness be your blanket. You have heard the whisper of the stars, and you know the truth. We are part of something magnificent. The night is finally still. The monitors have gone dark. The scientists have gone home, and the visitor is back in the deep. But the world is different. The air feels a little more electric. The stars feel a little closer, and your heart feels a little fuller. You have been part of a cosmic event, a moment in time that will never be forgotten. The silence is your reward. It is the peace that comes from knowing. Sleep well, traveler. The journey was long, the message was clear, and the rest is well deserved. The stars are watching over you, and they are smiling. Good night. As we close this chapter of our collective journey, it is worth taking a final moment to honor the sheer, stubborn endurance of the human spirit. We are a species of survivors and seekers, the descendants of ancestors who weathered ice ages and navigated trackless oceans. surviving a primordial soup that might kill a modern human in seconds, all so that we could be here tonight. We have taken the lead of our ancient fears and transmuted it into the gold of curiosity. We should be grateful for the chance to live in a time when the universe finally decided to break its silence. Our history is a long, winding road that bends toward the stars, and while it may bend, it never breaks. We have proven that we are ready to listen, ready to learn, and ready to take our place in the cosmic neighborhood. The 3i Atlas has left us with more questions than answers, and that is its greatest gift. It has given us a reason to keep looking up. Sleep now, with gratitude for the past and hope for the continuous, timeless future. History is still being written, and you are one of its most important authors. Sleep well. History bends, but never breaks.